This video is going to look at solving inequalities. Alright, so SOL A.5, A, B, and C. Remember, this is where we have the big but theorem and the flip-flop rule. So solving inequalities is just like solving equations, but if you multiply or divide by a negative number, then you have to flip the inequality sign. Alright, and then we also have where if you want to change the order things are written. So if I have 4 is less than x and I want the x on the left side, I can do that, but I also have to flip-flop the inequality. So 4 is less than x is the same thing as x is greater than 4. Other than that, we are going to solve inequalities the exact same way that we did equations. It would be the same properties that we would use to justify our steps. So if you need another look at that, go back and look at the A.4 video on solving and using properties. So we're going to go through one example here. I'm going to solve this inequality. So the first thing I need to do is combine my like terms on the left side. So 4x minus 11x would be negative 7x minus 5 is less than 23 minus 3x. Then I want my x's all on the same side, so I'm going to add 3x to both sides. I now have negative 4x minus 5 is less than 23. Add 5 to both sides so I can get x by itself. Negative 4x is less than 28. I'm going to divide by negative 4. When I divide by negative 4, I have to flip my inequality sign. That's the big but theorem. 28 divided by negative 4 is negative 7. So x is greater than negative 7. I can also graph that solution on a number line. So I'm going to put negative 7 in the middle. And then we'll put some numbers that are greater than negative 7 and less than negative 7. X is greater than means I put an open circle at negative 7. If it were greater than or equal to, I would close in that circle to make negative 7 part of the solution. And then I'm going to draw my arrow to the right because those are the numbers that are greater than negative 7. I can always double check my arrow by picking a number that's underneath it. So if I put negative 5 into this inequality, negative 5 is greater than negative 7. That is a true statement, so my arrow is in the right direction.